All right, more quadratic formula fun. Today, deriving the quadratic formula, and we're going to skip a bunch of stuff, keep this short. What would happen if we tried to come up with a way to use uh, the equation here uh, and completing the square to see what happens? So let's give that a shot. So if we set this up and get rid of the c value, we have to factor out the a, which would give us this over here, x squared plus b over a x plus something minus c. Now I could go ahead and divide by a. The question is, when do we want to do that? Let's do that in a little bit here, okay, when we are ready to solve this. So first things first, half the middle term squared. This is going to be kind of interesting in that um, half of b over a is going to be b over 2a and then squared, right? If I multiply that by a, one of the a's in the denominator is going to go away, and I'm going to end up doing this. Well, you know what? Yeah. So we're going to add plus b squared over 4, and there's only one a because it canceled when you multiplied that. Okay. What I've done now is I've created a perfect square. This says a x plus b over a quantity squared equals, and it'd be nice if I had a common denominator. We'll figure that out as we go, but right now let's go ahead and write this as b squared over 4a minus c. Okay, so it would be nice if I had this here, if I had a 4a, so I had a common denominator, right? That means I got to multiply this by 4a. So I'm going to rewrite this as ax plus b over a squared equals my common denominator, b squared minus 4ac. Now that should begin to look familiar. We want to divide by a, so when we divide by a, this becomes a squared there. Okay, those cancel. Now, I would like to take the square root of this and this. By doing that, that gives me x plus b over a equals, and notice that this is a perfect square, right? So that's just going to end up being over 2a when I take the square root of it, and in the numerator, the square root of b squared minus 4ac. Okay, so next we want to subtract. And I actually made a mistake up here, you guys. I'm going to go back and correct it. Let me do this in purple so you see my correction, right? This should have been 2a. This should have been 2a. That means this should be 2a. Half the middle term, right? Okay. Let's go ahead and subtract b over 2a from both sides minus b over 2a from both sides. Nicely, notice that I have a common denominator already. Therefore, x is equal to my common denominator of 2a, negative b. This should have been plus or minus the square root of b squared minus 4ac, and you've got your quadratic formula. Pretty cool. Not that you have to derive that, but I think you ought to know where it came from. There's a couple of things I want you to pay attention to, specifically this negative b over 2a. Notice that if this goes away, all you have is your x-intercept. So if this became 0, you've got your x-intercept, um, or your x, the value of the x vertex. Um, Pretty cool. The other thing is inside here, we call that a discriminant. Normally we would teach that. Not a big deal. If the discriminant goes to uh, 0, right, there's only one solution. If the discriminant is positive, there are two solutions. And those are two real solutions, I should say. And then if underneath the radical is negative, there are two complex solutions, and we'll get that in the next unit. All right. More quadratic formula.